Now let us consider the one of the important topic which is called mesh analysis, or it is also called as the loop analysis. So mesh is nothing but it's any closed path in the network, and it cannot be further divided into the another mesh. And sometimes mesh analysis is also called as the loop analysis. So loop is nothing but it is also the closed path in the network, but we can split the loop into the another mesh here. Okay. So in the mesh analysis, we are going to apply one of the concept called Kirchhoff's voltage law. We are going to apply. As per the Kirchhoff voltage law, it states that the algebraic sum of the voltage drop across the resistance will be equal to the algebraic sum of the voltages across the voltage sources. So in order to explain the KVL, let us consider the circuit as shown below. I'll consider a simple circuit which consists of the one voltage source with the two loops, and we have the in the mesh 2, let us consider another voltage source. So let us name this one as the voltage source V1 and the resistance as R1, R2, R3, R4, and this voltage source as V2. So here we have two meshes are there. So in the mesh analysis, we are going to find out the mesh currents we are going to find out. So let us call the current in this mesh is called as in the I1, and the current in this mesh can be called as the I2. So in order to perform the mesh analysis or the loop analysis, we have to follow the certain rules we have to follow. The rule is that, so the direction of the current, usually it will be taken in the clockwise direction, and the clockwise direction currents will be indicated with the mesh 1 as I1 and the mesh 2 as the I2 here. And for the voltage source, in order to apply the KVL, we are going to follow one analogy. That is, if the current entering the negative of the battery and leaving the positive, we are going to take that is the rise in the voltage, and that will be considered with the positive sign, it will be considered. So similarly, if the current entering the positive of the battery and leaving the negative, we are going to consider that as a drop in the voltage, and we are going to consider that voltage with the negative sign, it will be considered here. And also, if we are applying the KVL for the mesh 1 and the resistance R2 is common between the mesh 1 and the mesh 2, when you are applying KVL in the mesh 1, so usually we are going to take the difference of mesh 1 current minus the mesh 2 current. So similarly, when you are applying the KVL in the mesh 2, and the current through the R2 can be taken as mesh 2 current minus mesh 1 current will be taken here. So by using this basic rules, we are going to apply the KVL for the mesh 1 and the mesh 2 in order to find out the unknown currents I1 and the I2 here. So now let us apply the KVL by using this concept. So apply the KVL for the mesh 1. So in order to apply the KVL, others let us begin from the voltage source. That's the analogy we are going to follow. So since the current entering the negative of the battery and leaving the positive, we are going to take that with the rise in the voltage V1, and the drop across the resistance will be taken with the negative sign multiplied with the current I1, that is minus R1 into I1, and through the resistance R2, the two currents are flowing. One is I1, other one is I2. The difference of I1 minus I2 will be taken, and there is no rest of the part. There is no resistor here, so that is equal to the 0 here. Now segregate the I1 terms. So here send this resistance to the RHS part. So this will become plus R1 into I1, and here it will become plus R2 into I1 minus R2 into I2 will get here. So let us simplify this one. This segregate take I1 common. So I1 will be equal to the R1 plus R2 minus I2 into R2. Call this as the equation number 1 here. So we can write like this also, or else we can write like this one as also as this will be equal to the V1 we can write. So either we are going to write in the LHS or RHS. So usually let us write in the RHS as V1, the known voltage source here. So similarly apply the KVL for the mesh 2. Apply the KVL for the mesh 2. Let us begin from the voltage source. So the current entering the positive, leaving the negative. So it's a drop in the voltage minus V2, and drop across R4 will be taken at minus I2 into R4, and to the resistance R2, the two currents are flowing I2 and I1. So we're going to take the difference minus R2 into I2 minus I1, and the drop across the R3 will be taken. So minus R3 into I2 is equal to the 0. Let us separate the I1 terms and I2 terms. So we are going to get like this. So it is minus, if you segregate, it will become minus R2 into I1 plus I2 into, separate the terms R4, R2 and R3. So it will become R2 plus R3 plus R4. So that is equal to the minus V2. You are going to call this as equation number 2 here. So we apply the KVL for the mesh 1 and mesh 2. We got the equation number 1 and 2. Let us represent these two equations in the matrix form so that we can find out the values for the I1 and I2 by using the Cramer's rule or by using the calculator. So write in the matrix form. So here we have the known values R1 plus R2 and the distance minus R2, and here we have minus R2. Let us take I1 common, and here we have R2 plus R3 plus R4, and unknown currents which is I1 and I2, and the known voltages which is V1 and minus V2. So in order to find the current I1 and I2, we can solve by using the Cramer's rule, or we can solve by using the calculator with the two unknowns in the calculator. If you have the three meshes, we will get the three unknowns, and we can solve by using the calculator or the Cramer's rule here. Problem based on the mesh analysis. This is the basic problem. So here we have the circuit which is given. So here we need to, by using the mesh analysis, we need to find out the voltage V3 across the 40 ohm resistor. If you look into the circuit diagram, we can see there is a dependent voltage source is there. That is the current dependent voltage source. The voltage of this one depends on the current through the 10 ohm resistor. So whenever the circuit is given, first we need to identify how many meshes are there. So based on that one, we need to find out, consider the mesh currents. So here mesh 1, mesh 2 and mesh 3. Let us consider the currents in the mesh 1 as I1 and current in the mesh 2 as I2 and current in the mesh 3 as I3. So here the current I is same as the I1. So we can write, we can make analogy. So this I will be equal to the I1. I is equal to the I1. So let us start apply the KVL for the mesh 1, mesh 2 and the mesh 3. So let us apply for the mesh 1, apply the KVL for the mesh 1. So start from the voltage source. So the current entire negative leaving the positive, so it's a rise in the voltage. 100 minus the drop of this one is 10 into I1. The I1 is the current flowing to this one. And here 20 ohms, there are two mesh currents are there. One is I1, other one is I2. So this will be taken as minus 20 into I1 minus I2, since we are applying the KVL in the mesh 1. And similarly for 30 ohms, the two currents are there. That is minus 30 into the two currents are the I1 and I3. So the difference will be taken as I1 minus I3 is equal to the 0. Now let us aggregate the I1, I2 and I3 terms. So we will get like this. So 10 plus 20 plus 30, this will become equal to the 60 ohm. 60 I1 minus, so 20, there is only one I2 is there, minus 20 I2 and I3, so only I1 I3 is there, so minus 30 I3 is equal to the 100. Call this as the equation number 1. So similarly apply the KVL for the mesh 2. So KVL for the mesh 2. Okay, start from the voltage source. So the current entire negative leaving the positive, it's the rise in the voltage. So 30, okay, minus, so let us see what we will get here. 30, so this is a voltage source and the current entire positive leaving the negative. So we are going to take it as a drop in the voltage. So that is minus 15 into I and minus, so the drop across this one will be taken as the two currents are flowing. One is I2, other one is the I1. So since we are applying the KVL in the mesh 2, it will be taken as the current I2 minus I1 is equal to the 0. And also we know that this current I is equal to the I1. Let us substitute this I is equal to the I1 and find the equivalent value. So it will become 2, 15 and 20 will become minus 35 I1 and 35, 20 and 15, this will become 20. So plus 20 into I2, so that will be equal to the 30 will get. Call this as equation number 2. Call this equation number 2. So similarly apply the KVL for the mesh 3. apply the KVL for the mesh 3. So you can start from this dependent voltage source. So the current data negative leaving the positive. So this is raising the voltage. We can take this one as 50 I minus the drop across the 40 will be taken as minus 40 into I3, and here the two currents are flowing, one is I3 and I1, so minus 30 into I3 minus I1 is equal to the 0. So there is, if you come back here, no other resistors are connected, we'll get like this here. So now as we know that I is equal to the, this I is equal to the I1, I is equal to the I1, let us substitute here, so that we'll get 15 I1 minus 40 I3 minus 30 I3, minus to minus will become plus 30 I1 is equal to the 0. So let us segregate the I1 and I3 terms. So 30 plus 15 will become 45 I1 minus 70 I3 is equal to 0. Call this as the equation number 3 here. So you got equation number 1, equation number 2 and equation number 3. So let us represent all three equations in the matrix format. Let us represent all these equations in the, so we got equation number 1, 2 and 3. So let's make small correction here. So here minus 15 I1, if we substitute I is equal to I1, and minus into minus will become plus 20 I2. So minus 15 plus 20 will become plus 5 will get here, sorry, plus 5 will get, so this will become the 5 I1 will get here. Make the small correction here. That is minus 5 will get here. Make the small correction. It is minus 5. If we send to the RHS part, it will become minus 5 I1 will get here. So we got equation number 1, equation number 2 and equation number 3 we got here. So let us represent all three equations in the matrix format. So time being the circuit, we need to find out V3. So just I've written this part of the network. Okay, so represent all three equations using the matrix format. So equation number 1, we have the 3, 60, minus 20 and minus 30. From the equation number 2, we have minus 5 and I2 is 20 and there is no I3 term, so let us make it as 0. From the equation number 3, we have 45 and there is no I2 term, let us make it as 0 and minus 70. Okay, with the three unknown currents, I1, I2, I3, with the voltage levels, this is 100 and this voltage will be equal to the 30, and in 3 there is no voltage, so let us make that as 0. Okay, so we represented all three equations in the matrix format. Let's solve this one by using the matrix in the calculator by using the three unknowns. So if we solve by using the three unknowns, we'll get the value for the I1, I2, I3. So the value for I1 we are going to get as 3.64 amps, and the value for the I2 we are going to get as 2.41 amps, and the value for the I3 will be getting as 2.34 amps will get here. So these are the three mesh currents we are going to find out by applying the concept of mesh analysis. So in the problem they ask you to find out the voltage across the 40 ohm resistor, which is called as V3. So since in the loop 3 the current I3 is flowing the 40 ohm, so we can write V3 will be equal to the 40 into I3. So I3 is 2.34, so 2.34 amps. So we'll get the value for the V3. So this V3 will become equal to the, so 40 into 2.34 volts, this become equal to the 93.6 volts will get here. So we got the value for V3, which is the voltage across the 40 ohm resistor, by applying the concept of mesh analysis. Thank you.